So we saw this linear transformation yesterday, and also linear systems earlier, that how these equations could be evaluated, symmetric equations to be variable equations, and they're just transforming it to the matrix format. And they are determinants of transformation. They are talking in terms of vectors. That's what they say. We need prerequisites are there to understand the eigenvalues. All of you can come closer. All of you take your books and draw these vectors. This is the unit vector. The one box is 1 unit. So also draw and also understand what those values are and how many boxes it has covered. Okay. Understand this red one. Why they are written this 1 and 2? This 1 represents x-axis. Where is that? This is my x-axis. So how many cubes it has covered? Only 1. So 1, that means it is pointing here. How about this 2? Why? So 2 boxes it has 2 consumed. 1 box, 2 box. So these 2 boxes it has covered. So this is its x-axis. This is its y-axis. So the point, both the points are meeting is here. This one. Alright, so that's why it is written as 1 and 2. Next, how about this one? X is 3, y is 0. X is 3 and y is 0. That's why it is coming exactly on the axis itself. X-axis. It does not go above. Alright. Draw. Other. So this system of vectors can be represented into matrix.
Why we can be 0 and 1 or 2? Because we could have changed also. It could have become 1, 2, 3, 0.
You can write that also. But he said something. You just listen to this. I had J hat. I plus J as equal to I J. X and Y. X and Y equal. Okay. These are X for X axis coordinates. We'll say as I. For this one, we'll say J. Okay. You can just name them. Listening?
Eigenvector is scalar values.
Eigenvalues. He is explaining presently eigenvectors and eigenvalues. So presently he is using the vectors and its behavior to tell you where how can understand the eigenvalues in the using the vector formats. Understood what he is saying with these number of errors?
So we take
Which one? This one?
yellow color.
Yellow color. This one. These things.
Yes.
You can understand what he says. He's trying to say, whenever you take the vector like this, for example, this is one of the vector, and if you stretch it, and if you try to transform it, it says the reference line that you're taking, or the next line that is coming, or after transforming, wherever you go, that this kind of a marking or this kind of vector will not go anywhere. It will be extended in the same line. Okay, they follow the same line, they say. And so in this direction also they follow the same. So like as you're saying, you have your option with the y value. So definitely you are saying I have only three as a value, which is going to expand. So if I ask you to expand again and again, you expand 3 by 3 every time. Alright, but where do you expand? Where is the space availability where you go and expand yourself or scale yourself? How do you scale? You have only one position, x-axis or x-axis plus or x-axis minus. Y is 0 always, where is move? X, in other side. So that's why it is saying, wherever you move, your movement or transformation that is happening, that indication, the new transformed vector will be overlapped with the original. You will not see two lines. You will see one line only going one of the other.
Parallels.
Not parallel. They will parallelly to the vector along with the coordinates or along with the that 1 minute again. You understand this?
There is the what is that the eigenvalue
Multiplier.
that multiply.
How you want to scale it? That is the number. So you
What
say
is the scalar factor? Then what is the
multiply.
eigenvalue?
Eigenvalue will come next. This much you understood? -1 and 1 was the unit vector which was pointed here initially. When we multiplied it by 2, now it is going to increase its length of the arrow. When you try to increase its length, where you increase it, in which direction? So the direction in which it is going will not be changing itself. Alright? Such one of the properties -1 and 1, which is 45 degree, will be going there only. Any other angle is there, then it would have changed if you multiply with any other number. Alright? 2 into -1 and 1, obviously you get the linear value. -2 2, -3 3, -4 4. Get it? Those values will obviously x and y values are same increasing. So obviously it go middle. 45 degree.
So why you have different?
They are showing one of the possible behavior of vector where it will not change even after applying some transformation. Even if I try to change the matrix values, it will not change the direction in the same. Correct? So such possibility is -1 and 1.
we are multiplying with 3, 4, we will explain.
So where it is not taking its another angle and not going anywhere.
So -2, 2, -3, 3, they are once coming on the same line.
Obviously, you try it, replace it 2, take other number and try it. Where that point will go, will not go other than the direction.
So this is linear transformation.
No. Let's see again. This you understand? Okay. So it says knocked off means it is going away from or getting distracted from the original place of its original position of the vector initially. So presently the vector is here. When I scale it or transform it in another way, okay, scale is just increasing the vector. When you transform it, its values will get changed and it will get distracted from its direction. So when we expand it, so its original direction was this one, now it is at this place. Alright, that's why we are saying it is going to get knocked out. So these vectors which are associated with the values, I mean here is associated with this eigenvector with the 2 which is increasing its width, length along with its multiplied value. That value will be an eigenvalue. So what is that eigenvalue doing here? With that explanation and with that understanding,
It's linearly transforming the
exactly stretching it. Right? How much stretching it? Who is telling? Eigenvalue are there. So if I put 4, my 4 is my eigenvalue because it is telling my vector to expand in that length. That's not. So this is
eigenvector is
This is
the
the property of this one.
also that one. Which multiply 2 dot 2 eigenvalue. Okay. Understood? So such vectors which are going to participate in such behavior of not changing the direction but still expanding or scaling will be the eigenvectors. Okay. If you are clear, we'll go ahead.
So here eigenvalue will be my eigenvalue.
Eigenvalue.
Eigenvalue will be my eigenvalue is
2 we multiplied, you understand. Over 3.
so that is the eigenvalue.
Okay. We took that 3 initially. We are saying something here. Stretched by 3. Stretched by means expanded by 3. 3 boxes initially. We told you, right? From here we put that first table here. This one. We have stored 3 boxes, 1, 2, 3. This one. Alright. That's what we have taken from here. It was this -1 and 1 was here actually. So that we have multiplied by 2. It has got also stretched till here by covering 2 boxes. This is 1 box, this is second box. Okay. Stretched by 2, stretched by 3 boxes. I hope all of you understood eigenvalues and eigenvectors. Okay? Yes, no? As Chandrakant sir is saying, some keywords, whatever we are having on the slide, if you're not getting that, put that keyword on YouTube and you'll be able to get the videos. Okay? And you'll see animations like this. You can also see here, obviously, but we can also talk more about the concepts here. And whenever we have the keywords, if we find the keywords difficult, you can also look for the YouTube or you can also look for ChatGPT to get it. The overall linking of them and explaining them, I use YouTube. Even if you can ask here, I'll be able to explain. All the visuals, like this kind of things, take some time. So those kind of things you can obviously have a look at it. And if you find it good, and if you also understand what is there in that, you also share it with the group. So that everybody can look for that, because everybody may not be looking for all the keywords and everybody is not able to find the right video. That you have understood. Okay? So that's why we share it whenever you understand. And even if they can ask for that, obviously you can solve it. Alright? Okay. So we just found one keyword called eigenvector and we tried to understand what was that. And we achieved that in no time. Alright? Okay. Yeah, we discussed this one. No problem. Understood? So assignment, how many of you have done the assignment and how many of you taken cross two matrix plus two cross two matrix? So how many vectors you are adding? Four vectors.
And two cross
Two cross?
two.
Both are added. Both are added.
Yes. How do you do that?
Why you are adding both?
Simply I will add how to draw how to get the result.
So what you're trying to do is the first question.
Here adding simply adding the
No, I didn't get the final solution, but how can you say both of them are vectors and I'm adding them? I have I and j. I have I and j. So for I have one vector. For j, I have another vector. That's my one matrix is consuming for two arrows. So plus another matrix we are taking for another two arrows. So I have four arrows on my plot. So when I add it, I'm getting the two arrows. So obviously it is like two separately calculations you are doing. Obviously in the nine matrix you got two arrows.
So how to draw this concept? Yesterday we looked at two cross one matrix.
2 cross 1.
Correct. 2 rows, 1 column. It is getting answers. But in the 2 cross 2 cross
2 cross 2 into 2 cross xy. 2 cross 1 xy.
Yes.
Xy you tell me. How much? According to this one. 2 cross 2 right? ABCD.
Not done this name. So they took 2
2
cross and 2 cross 2 cross 2.
2 cross 2
And 2 cross 2
cross.
plus 2 cross 2. It is same like you are doing two separate numericals. At the end, for 2 cross 2, you will be getting one answer.
It is not getting a linear calculation.
That's what I am saying. So when you take one matrix, what will be the order of the matrix? This is 2 cross 2. What will be the answer I will be getting here order? If I transform it with one more column matrix.
2 row 1 column.
2 into 1.
Obviously,
2 row 1 column.
right? 2 row 1 column. Correct? So now what I mean is you will get one arrow here. This is one arrow, one matrix. One arrow. In your case, you are getting two arrows. Correct? In your answer, you are getting two arrows. That means you are doing this kind of a calculation 2 times. In a single shot. That's it. So you can do individually also, same answer will come by taking one matrix separately and one matrix separately. Same problem. And you will get the same effect. So that will be simple to draw answer.
But how to draw this one?
Now obviously we'll try it.
Because yesterday we only done 2 row 1 cross.
So basically, do you understand vector addition?
Yes.
Okay. Tell me how vector addition will be done. Tell me.
X and X, Y and Y.
X and X, Y and Y. Okay. Tell me values that you have taken yesterday for addition of that, and let me know how can I add them. If this is my for example, I have a line here, and this is the 0 at the middle. Let's not talk about the vector now. Let's talk about numbers. I have 2 and -3. Okay. First, I want to mark this one. I'll mark this one. This is so I'll mark here. This is my okay. And I say I want to add this number with another number that is my -3. Now, how do I add that number and where should I go? Now I am from here. I am here right now. Now where should I go?
Below. Right.
So next I should come here and stop becoming stop here. That is my what is this one? This is my -1 in the number system. This is my 0, this is my 1, this is my 2, this is my final position. Get it? In terms of number systems. So what is your displacement? Your displacement is 0 to -1. Okay. So if I say I change my numbers, I went from 0 to 2. I went from 0 to 2. Now I want to add this 5 also. So where my arrow will go?
to 5.
So I will add this one. This is my one of the quantity. This is my another quantity. That's why I add it. Alright. Same way in all the axes. Wherever I have y-axis values, I'll be adding those things. Alright.
So whenever we do from 2 to 5 elements, 5 digits, 2 to 5 digits.
Supposed to come
Because it is 5 subject.
2 plus 5 7.
That's it. Totally it is. Totally it is 7 number distance you should cover actually. I mean, I have not covered this thing. You actually have to go further. This is not 5. I marked it 5. So it should go 5 places actually. 1, 2, 3, 4, 5. Here it should come actually. This is 5, this is 6, this is 7. It should go actually 5 places. That is my addition, vector addition. Alright? Okay, so we understand with the numbers. Okay, how about the vectors? Let us understand. So I have a vector like this. And I have this point called, I'll write them as matrix. This is my 1, this is my 2, this is my 3. This is my x-axis, so I write that x-axis here. And this is my y-axis, I write them, this is my 1, this is my 2, and I write them as 2. So this is my matrix, where I am actually trying to put this. So another vector I have here. Another value. This is my 3. This is my 2. So I have 2 as a value of x. Y is my 3. So when I have this values in these vectors, I want to add them. So before that, what we do, we actually represent both the vectors in terms of matrix. So what we do, we just write a matrix of 3 and 2 and 2 and 3. Okay? And we wanted to scale them with a factor of. Okay, let us not multiply them, and let us only have the addition. Now I want to add them. How do you add them?
You can join the arrow marks.
You join the arrow concept.
Yes.
So
Join both the arrows, so we get a line of the graph.
join the lines. These both the lines we need to join.
Both the arrow marks.
Both the arrow marks.
Yeah, they are the points, and let's add them.
So from where should I add?
From that link.
From
That
here.
arrow. To these arrows.
Here like this.
Let's join both the arrows.
Let's join like this.
Yes. So this is the line represented by 2, 3, and 3 2s.
3. This is my 3,
Yeah.
and this is also my 3.
That line is the graphical representation of this matrix. 3 2 2.
3, 2, 2, 3 is the graphical representation of this line.
Yes.
How?
This 3 2s.
Points you are saying.
Yes.
Points it's mentioning. Okay. Correct. Coordinate wise, it is points only. X, Y, X, Y. X, Y, 1, X, 2, Y. Like this, insane. You understand that? You have a line And these are my points. This is my x1, y1. This is my x2, y2.
Let's multiply this matrix by a matrix of order.
No, we just will add the two values.
3 plus 2, 3 plus 2 plus 2. 5,
5. Theoretically, we have done the calculation. So we want the proof here the this one. So where those points probabilistically you can point 5 cross 5. This is 1, this is 2, this is 3, this one 4, this one 5. 1, 2, 3, 4, 5. So if I take this line here, so I have this point somewhere here. Okay. So if I look at my numbers, I have already reached to this place, which is my 3 step. Okay. So I just need to see how can I reach to that point. So how you will draw the lines with Yesterdays methods onto this diagram? Does it look more complex? Very simple. 2 arrows are there and 2 matrices are there. Nothing complex. If you do not have other values, I will do this. So that I can have one more plot here. Now, I use the method that I have explained yesterday. Okay. Then you tell me how you can solve it. Okay. First zero I take it. This is 3, that is my x-axis. This is 0, 1, this is 2, this is 3. So I use this as a line, another line. I use this 2 as my y value. This is my 1, this is my 2, and this 2 value I use it. I'll call this. Okay, I'm done with this one. So I started here. And I'm done here. So as you see, this distance you actually covered. Okay, when you went here, and from here you're going to start using that. You take this triangle, this distance over here. Okay. This is my 3. This is my 2. Okay? Again, this 3. This is my 3. This 2 is here. Okay? Next up. So I am here, I have traveled. X-axis, I have traveled this much. Y-axis, I have traveled this much. Next, I have to go on add something on my path. So I should take the y and 2. Y is the 2. Y is x and y 2 and 3. So in x-axis, where should I move? From here. Forward here, I should move how many points? 2 points. So this is my 1 point. This is my 2. So I move 2 points here. Okay. Next, I have to move 3 points above. So this is 1, this is 2, this is 3. 3 points I should move. Okay. So this is my 3 points. 1, 2, 3. So I move 3 points. So now I have reached to the end of my journey. My trip started at 0. By using those numbers, I started the journey. First, I have to go to 3 kilometers. From my home to 3 kilometers. From 3 kilometers, I have taken one more direction. 2 kilometers in this direction. Because this is my y value. Y axis I have moved 2 kilometers. From that point, my other vector told me to move 2 kilometers on x axis. Again, in y direction, it has told me to move 3 kilometers. So I have traveled 3 kilometers. So the question is, what is the displacement of the point or the path?
I see.
It's 5.
X is 5, Y is 5.
Any answer? I have taken this path. So we are not drawn the numbers for the next numbers. So this is my 2, this is my 3, this is my 2. And how about this one? 2. This is my 2, 3. Okay. Now you need to add these numbers with these numbers, these numbers with these numbers. Alright? So let us cover these numbers totally. What is this number? 2. This is 1. Let us find that. Let us take this part. This part. This is 3 plus over this part. So this is 5. This is 5. That is what we are trying to understand. Now, theoretically, I can understand. I have traveled a path. That's why I can see these numbers are coming. But where is my arrow? I have drawn initial arrows, but where is the arrows? How to see that? So with that, I can say my arrow will definitely come from origin to the end point. So this is my arrow. Because I finally came from this point to this point. My path may be different, but I have traveled from this one to this. If I travel to aeroplane, it is direct. I came through road. Don't exactly start that. But the distance I have covered, I have calculated, I understand. Origin to the end point. So my last or the final matrix is this one. Or the coordinates, the point, x, y. With that, 2 matrices, if you consider, 2 matrices if you consider, you will add both of them. Okay? And finally you get 2 cross 2 result. Okay? I have represented 5 and 5 as x and y one coordinate. In your case, you have to represent 2 coordinates. Alright? So you have to travel 2 paths. 2 paths you have to travel. Then you have to see where your path moves in 2 vectors. You have to use 2 vectors because the answer is saying it is 2 vectors. Right? That's why when you take a single vectors and try to find a resultant of displacement, then we are calling it as a transformation, not only scaling. Okay, transformation may be anything, in moving also, in expanding also. All right. Okay. I hope this demonstration has given you clear.
What's the difference between scaling and transformation?
Yes. So when you transform, this is my okay. This is one of the vector 3 and I just transformed into here. This is my transformation. How about scaling? I have this 3, 2. During the transformation, yes, during its manipulation, what happens? We will give like this. It's getting transformed, and it's also getting multiplied.
So if we shifting its place from one quadrant to other quadrant, that's an example.
Transformation. Quadrants are also changing, or coordinates basically are changing, and we are trying to. No, we are not saying during transformation scaling is not happening. Scaling is definitely happening. But individually, I'm trying to explain what are those. Scaling, when you say, we are talking about scalar additions or scalar subtraction. For example, I have the vector, unit vector like this. If this is 1, this is 1 comma 1. If I say I want to transform this one or to scale this one to 2 minus 1 minus 2 comma minus 2, where do you go?
Opposite.
Exactly opposite. So you come down here to be more scaling. Alright? So your scaling is you're adding the magnitude to the existing vector. The number you're adding. The number you're adding to the existing vector. So you're scaling. Okay?
So when we
Transformation is generally a word of changing its coordinates. Scaling and transformation both can happen at a time.
sir, when we do scales,
Why do you scaling? Yesterday only we answered. There was highway, Pune, and you and I were taking car, and we both did forward to throw to the petrol, and we need to push the car from the back. And we are not sufficient to push the car. That's why we need to add some more person to push the car. Correct? Why should we call the other person if you ask? Then we have an answer. We are not enough to push. If 3 people are not enough, we need to call everybody. 4 5 people to push. That's why we scale the vectors. Because there is a magnitude of any of the vectors that we are representing. That's why we scale them. How do we scale? We scale by multiplying. It's 1 person dot 2. Now 2 persons. Dot 3 persons. So you expanding with the factor.
sir, but we are adding the persons, it is increasing with adding the positive values.
You subtract it.
Sir,
Into minus and you
by adding minus 2, sir,
you subtract, you reduce.
it will reduce, sir. R is not moving, sir.
That's what it is going to reduce the not only reduce it makes an nullify and ask you to pull back because the direction goes down, you're negative. The direction is different. But total magnitude, what is the total magnitude? You have to see. Okay. You just have to see magnitude as one of the number representing a quantity. So to understand all these things, you need to have some examples in your mind. Else you will not be able to imagine what is going on. Okay, let us list out the safe side. Scalar. You understand scalar? So let us understand scalar. So what is scale? Firstly, what do you mean by scale?
Is that the measure? Is it instrument?
Measuring instrument. Measuring instrument. Any measuring instrument. If it is a small scale, that is what is used in class. Scale. Okay. A metric. Okay. So in scalar, we have only one parameter, that is quantity or value. That single value, like 29 degrees Celsius is temperature, room temperature. If I ask you, is having a direction? No, you just say it's a temperature. So can you say where it is going? It's everywhere. So how can I measure it in a direction? You say there is no direction. There is no direction. It is having only value. That means it will be in the under the category of scalar. I have one more category called vectors. Okay, and it is not only the temperature. Your house price and house square feet area, 20 by 30 or 50 by 40. You write that, right? If you write that 30 by 40, you have the square feet being calculated. Do they have the direction? They have the direction. As I'm saying, 30 by 40, they are directions. Okay, and they also have the. Do they have the direction in both value and this one? Area is scalar or vector? Scalar vector. Scalar. How about the price?
Price is a scalar.
Price is scalar.
Comes down. Whereas area
No, no, no.
is constant.
No. Price is vector or scalar?
Price is scalar.
Scalar.
It goes up or down on a scale.
On a scale, agree. Range. But does it have direction?
No, sir.
So it comes in scalar only. So area is also scalar. So your ohms, square feet, accordingly the price will be both the quantities as scalar only. So you can represent them in matrix. And you can call them as scalars. No problem. Fine? So they are also one of the examples. I'm just trying to give you the general example. Alright. I have given an example of
How do you explain the same with speed and velocity?
speed and velocity.
How many kilometers per second?
Kilometer per second. Per second.
So the speed and velocity mean the same thing? Or they different?
No, they're different. Speed and velocity are different, and the formulas and the parameters related to them and how their relationships are very different. Speed, acceleration, velocity. They are interrelated but not same. Okay. Does the distance is having the is a vector of scalar?
Scalar scale.
Distance. Distance from A to B. Okay, from B to tower.
It can become 20, 21, 22.
Okay, so we don't have direction. I can go anywhere from this place. 20 kilometers here, 20 kilometers here also. I can go. My question is B to tower is scalar vector?
Scalar vectors. There are directions. This is our
B to tower.
Specific direction.
Not specific direction. We need to have a specific direction and the value. Do we have that? My question is simple. Do we have the direction from B to northward one? We have the direction. We have the arrow ready. Do we have the number which defines the distance between B and northward? Do we have?
Yes,
We have. Then we have the value ready. We have the value ready. We have the direction ready.
So distance is it becomes vector completely.
Distance is the one of the value in the vector. In vector, we have 2 quantities. One is the direction. For example, in northeast is one marker quantity. 20 kilometers northeast is one vector completely. 2 components of one thing. In terms of, generally I'm explaining. Mathematically, I'll explain it differently. Got it? Okay. Yeah, in terms of kilometers, will be kilometer will be your you have the distance you are actually measuring. How much distance you covered per second? You are measuring. So that's my quantity. I am measuring quantity because before this a number will come. So with this speed, where you are moving or not moving? Where you are moving, you are not telling me. If it is force, I would have told that is somewhere you are applying, that means somewhere you are having the direction. Even if you are riding a vehicle, you have a direction. So then your speed is going to have, if this is a speed, the speed is going to have the vector. Okay? So your direction and magnitude together defines a vector. That's it. Alright? Okay. So what examples we can keep in our mind to remember the vectors?
Magnitude and direction.
Magnitude and direction. Any other examples?
So gravity can be the example of
Obviously, obviously.
what is the falling, how you are moving.
It has a direction. If it is going any other way also, then forces will be have it. And with magnetic field we have it. Static charge, force between two static charges. Magnetism, surfacial magnetism. They have. That's why we have those lot of rules which involves these vector symbols in physics. Be with the arrow on top, you might have seen those things. Those will come only when they wanted to say where the direction is the value what I'm writing. Okay. Okay. So we have this force, speed, velocity. Velocity will be scalar or vector.
Yes.
Velocity.
Velocity vector. Yes. Next.
So what is velocity, sir?
Velocity is velocity formula we need to tell.
Based on that, we have discussion. The time.
But formula
dx and dt.
very simple. dx by
dt.
b equal to dx by dt. Okay.
So even speed is scalar. Even speed
Yes. Speed is
scalar.
speed is scalar. Speed is scalar. How?
We just tell only speed, sir. Not direction we say, sir. If we say with the direction, sir, 20 kilometers per hour, with the direction, with the specific, then it's a vector, sir. We just say in
Quantity.
quantity, quantity, yes, sir.
Okay. Let us take a formula for velocity. Okay. D by d. Tell me if you have a reference or example there. Energy can be only scalar. Because temperature is one of the form of energy. Yes, B equal to d by t. So you are covering some distance with respect to time. So you are not talking about direction again. Okay. Again, you are not talking about distance. So, yes is okay. What is speed formula?
d by dt.
Divided.
So go through the definitions.
Of
Speed and velocity are
both the
different.
different only. Definition. Okay. Okay, here it is. It's
X vectors. Then what speed?
We'll see speed and velocity is the directional speed of an object in motion as indication of its rate of change in position.
Change in position.
So there is a particular frame of reference.
Obviously, time reference. Direction. So we have that as a term. Speed is measured as the ratio of distance and time in which
Speed
the
is
distance was
scalar.
covered.
Speed is scalar.
Like in any direction, it shows a part specific direction.
It is not mentioning this one,
So
but
what's
if you go in any direction, speed is measured as the ratio of distance. So it can be it can only be a scalar quantity because it is not mentioning the direction. Speed is scalar quantity. Yes. Next, any other thing?
Velocity is also vectors.
Velocity. Velocity vector. Okay. Next,
Density.
Density is a scalar.
density is scalar.
Speed is scalar. Volume is scalar.
Volume. Area.
Time.
Time. Mass or weight. Weight. Gravity. Momentum can be vector. Okay, I hope you understood how it is breakdown. All right. Okay. So you clear with this? So I hope all of you are okay with the vectors and its data structure and its understanding. This is in terms of physics and what we understand in real time. Whenever you represent them, these things, you only have values. And those values can be represented in terms of matrices. Alright? And these vectors can have, will have the values in matrix as vectors. Okay, vectors in the form of 1 cross 2 cross 1 matrix. 2 rows, 1 column matrix represent 1 vector. Alright? In any of the coordinates. So that we need to understand. Okay. Now, any questions you have? We did this example yesterday, and I hope you understand today whatever we have done. Now, any questions?
Sir, it's just to figure out 2 into 1 was maximum solution. It's just to find the shortest distance for the to plot it.
Correct. So whenever we presently we are taking only 2 vectors. That is just to study. When we have multiple vectors, we wanted to manipulate them. Okay. And how can I understand those vectors and where can I use them? Because I have to use them. Programming also. Where can I use them? So whenever we are going to study the values in terms of matrices. Okay, and these vectors are not vectors. They are actually the points on the coordinates. Okay. So I have just drawn two random points on the plot. So such random points on the plot, I need to address them. Okay, I'm generalizing this concept now. For example, I have these many points here. This is my pattern of disease, where this is my population and this is my age group. Specific age group is getting this kind of a disease. So I have to have a prediction with the machine learning. So it is trying to find these are the group of people which is having the disease. So these are my points. Similarly, vectors. But how can I represent those points and how can I handle those points? Here is my mechanism. I want them in my tensor. I want them in my tensor. This is my tensor. This is my tensor, which contains again more number of matrices. So this my tensor is a compact structure of storing my matrices or lot of vectors compactly. And my programs know how to process this kind of data. But you have to tell me this data in this format. How do you write it? You write it in vector format. You convert them into these points. So that's why these are not actually the points, they are actually the vectors. I'm being very good. I can say this is my one vector, this is my second vector, this is my third vector. Presently we are studying this. In future, we will not look at this. We look at these things. Got it? So in future, we wanted to focus on points where we are going to handle them as a data input point. Like how we are asking user input. Please enter the 10. Please enter the 20. I want to add the two numbers. You are asking. In future, we will be provided with this data, and you have to handle that data. How do you handle that data? Because they are in coordinate formats. How do you handle the coordinates and their distances from a y-axis or x-axis? How do you store them in matrices? And how do you manipulate the matrices? How do you scale them if I tell you to scale them and see if they are able to, if you zoom them, if I ask you to zoom them, how do you zoom them? I want you, they are very close, I ask you to zoom them. How do you zoom? You just scale them, right? You just tell them to move ahead in other directions. And you just equally, then you ask them, equally multiply with this one. Every vector you multiply the same number. And you say, okay, we have scaled it. Same space, scale it. And you say, okay, now zoom. See, I have zoomed it. How you want to zoom? Because you understood basically how you can zoom. Get it? Basically, you are trying to understand how you handle those points. Basically, nothing more. So, key mechanism we have in mathematics is vector formats to handle those coordinate points, and it's very important. All right. In machine learning and in AI, we have intents of such points and significance of each point on the plot. Some points will be here, some points here will be here, some points are here only, some points are here, few points are here. So which are the points which are having closer to this one and closer from here? You have to find out. Three groups are here now, and some of scattered few points are here. So which one you give more importance, from the disease angle or from the population angle? You'll be given a lot of angles to understand the data. Same data, same sheet, represented on the plot as it did on the scatter plot. You have pointed out a lot of points. Now you have been given not those or x, y values. You have to not to use the plot, but you have to use the matrices, plot them as input values with one color, another color with the output values, and you see how the transformation happened. In before 2020, this was the population in these countries, And after 2022, this is the new colors, red colors or green colors populations. So you map. So how do you monitor those points? How do you name them? And how do you point each of the values, and you try to monitor their changes, where are they moving in the x direction, are they moving in the y direction, and how do they move? They're not moved linearly like x axis y axis. They move 45 degrees, middle. So how do you monitor this? Okay. They moved a little, not exactly more 45. They have moved for 40 degrees. How do you measure this change? Small change happened, but you have to monitor the small change. For example, patient's heartbeat is there. The heartbeat log is his usual pattern. But I have to find out between that log there is some crispy sounds coming because the person is having some problem in his heart. How can you find out that small crispy sound that is coming in the heartbeat sound? That pattern is there. In that pattern, you have to zoom in on the data and try to find that irregularity in the pattern. The coordinates, these coordinates only that we are writing here. The only thing is we are writing only two coordinates. There are a lot of coordinates. We have taken only two coordinates of those patients. For example, 2 points we have taken because we can't take all the points. And we study only 2 points. How do we access them and how do we manipulate them? Alright? That's why we are studying those points with the help of vectors. That's why we told earlier that we are representing vectors in terms of physics different, mathematics different. In mathematics, because we are bringing them into mathematics because we are good with manipulation in mathematics. So therefore, a lot of formulas. Okay? And we are having a lot of applications in mathematical modulation. That's why we are going to have mathematical models ready to keep my machine learning model learn from the changes that are happening in the data. Okay? So my machine learning model is not a machine learning model, it is mathematically learning model. Get it? That's why these vectors are important. How you try to learn different data types to handle data from a user, and you got a lot of errors, and then you learn how to use that. That's what these vectors are. Since you are learning from the ground, and I'm hoping that you will be intentionally and seriously trying to achieve that small goal that I want to learn from the ground. That's what we give. That's what give you doubts as well as the convincing capacity to your brain. All right, and make sure that you understand it. That's why we are spending and stressing more on it. This is basic. Okay, this is where most of students as well as learners studying from home will not be able to get convinced of what the trainer is saying online. Okay? Because they will not be able to, people will not be there, who will actually convince, and you will not be able to ask somebody who understand what your doubt. Your doubt is very customized doubt, because everybody's personality is same, changed. Not same. Alright? That's how this concept has to be explained like this way. And you have to spend some time focusing on them. Got it? Okay. Now we learn something.
So, both we understand the vector in this way.
Okay.
This scalar will tell only what's happening.
Okay.
It will tell only what's happening. Whereas the vector will tell what's happening and where it's happening. So you answer those questions.
Exactly. Like same like force. How much it is happening
And where it's happening.
where it is happening. Both force will tell. Temperature will tell what is happening. How much is it? How much is the temperature?
It's increasing or decreasing?
Decreasing. But the force or the velocity that you are increasing will have to tell velocity as well as the direction. Both things are to tell. Okay. Let's go ahead. No question with the neural network introduction?
So is it the difficulty here is same for every reason? Because for BE, diploma, PhD, all the levels.
See, it is not the difficulty level actually. It is two-way. Okay. It is the convincing part. How and what tools we use to convince. That's one angle, the delivery angle. Another angle is the prerequisites students are already having. If students are, if these concepts are at 10th standard, till 9th standard, are they prepared to learn this thing? Is the question at 10th standard?
So only it is the calculation part.
Only calculation part.
Only how to calculate the.
That's what. When the teacher speaks one word, they have to make sense seriously what they are speaking. And that doesn't happen at that moment, right? Not the whole 10 standard years. That one moment, 1 second, when the teacher says that. She has to explain next thing. The whole story. About that, then whatever calculation she wanted to tell, students will automatically do it. Was that understood? Only one numerical is enough. One numerical and the explanation and the fun of the whole class, finish. In 2-3 classes, we will explain the whole lifetime vectors to students. So that's how it is there. So how you prepare your students and how your teachers will be, that's how makes difference. We learned in PUC. We didn't know what are vectors in we understand.
PUC also lectures will tell in terms of just the numericals. They will not plot the graphs and.
Exactly. See, what is the problem is students are so fearful of the marks. This will not let any person to become an engineer. If engineer is having fear, he is not an engineer. It's very truthful word. I'm telling on record. Record. If the engineer is having fear in his heart, his present is not an engineer. When he removes that, keep it aside on table and go. Engineers started on that day on second.
Because numbers they are not moving beyond 1 to 9. Within that much space only they are creating so much difficulty to understand. They are not going to bigger numbers like 50 or 100 like that.
That's right.
It's not like calculus or integration, differentiation or something like that.
That's what we need to understand why they are available, the base concept. Then only we can understand it. So there are displacement that is happening, but this displacement is not directly happening. We are having two vectors which are saying I will go first and you will come next. But obviously any of them, any two paths you are following, both are connected to your journey. You take this journey first or that journey first. From whichever direction you come down. If you follow the same path from the origin. That's what the vectors are. That's what I'm saying. When the teacher explains, immediately our fire spikes in our mind. If I ask something of marks to you, that fear of marks if you have in your mind and your heart, never think of becoming an engineer. Engineers are so rough and so raw. They will hammer the professors like anything. They have to cry. If in your lifetime, if any other lecturers have got cried because of question, on that second you understand that you became an engineer. Else you are not your usual person, like how people are going to study like commerce. Same person, no change in that. Just you have a degree and that person is saying I am from commerce.
Actually, all lecturers of engineering, they will be among the students like anything.
Because of your fears, they do not explain. And you cannot blame. They are good people and they are doing their duty. You are not doing your duty.
Even in the evaluation of the internal assessments, even you cannot go and say it's a if you get any marks lesser than the prescribed. You cannot say.
Really,
Yes.
I don't want to divide, but it is reality. Unless and until you ask what you want, you will not be getting it. Okay? When you order one dish, one plate, if you bring one, will you be okay? Why? Your immediate response is order two, why one? Order full definition of vector and diagrams and in the animation also to understand why only the numericals. You asked it, no. I paid a full fees, you know, not 1 rupee also missing in my slipper. What happens? Get it? I understand the education system to the core because I am from the background, so I understand. I have a lot of things in my heart. I am not openly enough. I am pushing it. I understand it from the core.
Yeah, so by the base of these recently the construction materials, they are both still giving in this circumstances. The video students of the our same college, they have got so off.
Yeah, obviously.
They say
That's
you
what
use
happens.
zeros. You use zero in internal assessment.
Obviously. We just don't have to fear of asking what I don't know. Okay. If I'm having an accident, should I shy asking where is the hospital? What happens if I don't ask? Same situation you should become classroom also. That is a small incident. This is big incident. Okay, right? For whole lifetime, you will think that I have grown up. So if I ask this is a smaller doubt. I should not ask in the higher classes. When you become higher again, that doubt become again more smaller. You will not never ask this. School doubt, I should not ask in PUC. Most students will do this mistake.
So,
The PUC doubt they will not ask in engineering.
so these vectors, we just pass it in 10. So vectors we didn't understand then. Now it's coming back to what
It's clear, so clear to your answer.
It's not being done again. It is very important. Tensors, without tensors, machine learning speed will get slowed down if you write right. Tensors we wanted, so for tensors, these are the matrix we wanted. Matrix we are, vectors we are representing matrices. And in any of the studies that we are doing for image processing, for there also we need these values. Okay. In 3D also on that day we saw some values in an image is getting the having a mountain kind of a diagram we saw. Okay. In the middle there was a light. The only place where the light is there, the mountain like a structure was there. Okay. So those are actually the values in the coordinate in 3D system actually. That was in 3D. So in 3D you are representing some points again. Alright. They are not drawn like arrows, they just drawn the vertical lines which are having three-dimensional values, one each of the values. Alright. So if we just taken two values because we wanted to understand simply. Once you connect it to three-dimensional, then you have to have four dimensions. I can imagine this because I have gone through that rigorous training of computer-aided design. Okay, computer-aided design, where we'll be learning how to imagine points in space, lines in space. We learn this in C-side. P-side. In between. Yes. Cat. You understand that, right? Okay. So there we will be able to learn how to imagine this thing. With that, you can understand this very clearly because they are points only. How they are being placed, that will be very specific. All right. I think it's the time I have taken more. Okay. So understood.